for this one, we can calculate, gamma 1, gamma 2, gamma 2. Gamma 1 is what? It will have two vectors. The first one represents what? At time 1, the probability that you are in a state. And this one represents what? At time 1, you are in a state. Similarly, this one. At time 2, the chain is in a state 1, the chain is in a state 2. Now, how can we use this one to calculate this one? Phi. What does phi represent? Phi is phi j k. What is this variable representing? This variable is representing that it is the probability that the hidden chain is in state J and the symbol emitted is what? Right? Okay. Now, irrespective of whether the chain is in 1 or 2, that means alpha 1 1 or alpha 1 2. What does it represent? It represents chain is in state 1 and x is limited. The lower one represents chain starts in state 2 and x is limited. Right? Now, if we add alpha 1 1 plus, gamma 1 1 plus gamma 1 2 plus gamma 1 3, what is this sum representing? This sum representing that.
So পেনের কালারটাকে চেঞ্জ করা যাবে?
Oh, sorry. I changed it due to a difference. Can you see it or not? This gamma 1 1 plus gamma 2 1 plus this gamma 3 1. It represents that. This one represents at time 1, the chain is in state 1. This represents at time 2, still the chain is in state 1. This represents at time 1, the chain is in state 1. If you go there here, this path has this one. This path has
একটু
this
মাথাটা
one.
সরানো উঠবে।
This path has
Thanks.
this one. Right? Only we are considering the first part, where at time 1 this other and time 1 is this one, then we consider this one. Here is now getting this probability, and in the top, if we write gamma 1 1 plus gamma 3 1, then what is this ratio represent? This one is considering all paths that starts in 1 and generated the symbol x. This path is representing that in the middle it was in state 2 and at that time it represents symbol y. This one representing that at state 3 it was in state 1 and generated symbol x. In the top, we are considering only those where only symbol x and x are emitted. This ratio represents where the process is in state I, but only generate state symbol x. So this ratio in fact is representing what? Understand? phi1 1, then this ratio will be gamma 1 1 plus gamma 2 1 plus gamma 3 1, and then here it will be gamma 2. A general version of this one is from t equal to 1 to capital T, we want to sum gamma t I. Here. From t equal to 1 to t, with one condition. What is the condition? That the symbol omitted at time t is equal to k. Then gamma t I, this represents phi I and here p. So this equation actually is giving us, once we calculated these three vectors or these p vectors, then we can calculate this axis. Are we with this one? So now, if there is no problem, then we move on to the variable chi p I. What does this variable represent? It represents the probability. Oh, we have written it. The object symbol is O, and at time t, the state is R. At time t plus 1, the state is. That represents probability of the transition from I to j, and this object symbol sequences. Now, this is the definition. So, this variable somehow is connected with the transition from I to j. Question is, how can we calculate this? If I draw that diagram again, this is state 1, 1 and 1, this is state 2, 2 and 2, and this is t equal to 1, t equal to 2 and t equal to 3. Let's say we want to calculate chi 2. It says what? At time 2, all the paths that at time 2 are in state 1. Right? And after the jump, at time t1 the path is. How can we calculate this probability? This portion is represented by what? Alpha to 1. Yes, this portion is represented by. Then this portion is represented by a jump. And if we have remaining states here, that will be represented by, beta 3 j. Only one thing remaining here. Symbol limited here is 5 p plus 1 is y. That's what we consider. So if we have all four things together, then this represents up to this one, the symbol object is O1 to O small t. And we are in state I here, state I. Then a jump to state I again, here I. Then a jump. Symbol immediate is y, that means 4t plus 1. And then in the remaining path, we do not care which path we follow, but this symbol immediate r, the remaining path. Y plus t plus 1, t plus 1, t plus 3, and so on. So if we want to write this here, then this probability becomes alpha ti, then I to j, then phi j symbol is O t plus 1, then beta t plus 1. This says at time t we are in state I, this one, and this one is saying that at time t plus 1 we are in state j, and we needed a jump from I to j here, and the symbol has to be red. This is the, so this represents only two paths, and this probability is represented with the ratio with these two paths with respect to all the paths. That means so do I this one represents what? The probability that at time t you must be in state I. No other. So it considers all the paths that are through state I at time t with respect to all the paths. So when we call all the paths are represented by this one that we have seen in the last class. And all the paths, they are actually observe the same sequence but go through a state I should be the combination of this. This is as simple as this one is considering only fraction of those paths where actually at time t we are at state I. This one is guaranteeing this one, and from time t plus 1 to remaining we are in state j with respect to all paths that are possible of generating this symbol. But now here there is a gap. What is the gap? So this is I and this is j. This alpha j is considering this thing, this beta j is considering this thing. Alpha j is, sorry, alpha ti, all the paths that
I'm not actually fully understanding the concept.
plus 1 is j is all the paths that started from j at time. Then what are missing here? One thing missing here is we need a jump. And this beta actually is starting state, the symbol emission probability is nothing. That's why what we need here. So once these two variables are there, then we can. So we already have seen how can we calculate this one. Only one thing remaining, right? What is remaining? How can we calculate? You will see how can we calculate the new Pij? This new Pij is what? It is the ratio that at time let's okay, let me do another. This is I.
Shahir Allah.
And this is
Ekto. Thanks.
what is the probability that at time t you are in state I? All the paths that leads into a state I is and what is the probability that whenever you are I, a jump is there? That means at time t you are in I, and at time t plus 1 you are in j. There is a problem. What is the problem? It is just considering, this one is just considering only t. But you started t is equal to 1 to t is equal to 2. To cover up this one, what we need? T equal to 1 to T minus 1 and T equal to 1 to T minus 1. Why T minus 1 is there? Because when you are in T minus 1, only then you can have a transition to state J at T at time. But from this T equal to T, you cannot have another jump. That's why the limit will only go up to T minus 1. So by this way, you can complete the matrix. So the algorithm is very simple, really simple. It actually come to the algorithm. The algorithm is an iterative algorithm. What we are given, we are starting with a model. You can have this model actually given to you by someone, or you can have a random one, or you can have some experts who will build it very good. And also you are given a sequence of observations. From this observation, what you will do? You will calculate alpha Ti, beta Ti, then gamma Ti, then psi Ti. Once you calculate this one, then actually what you can calculate? You can calculate P bar, phi bar, and pi bar. That means once you have this alpha beta, then you can calculate this matrix P, phi, and pi. So actually you are calculating it. So for here you can do this. This circle is reducing. That means you are going toward the optimal. So the circle is reducing means you are actually approaching to the what is the local minimum? The probability that you calculated based on the current model when compared with the previous model, just immediate previous model, is less than a very small. This is the fact. Okay? And when this occurs, you will stop. Otherwise, you keep looking for a maximum number of times. So, I think the algorithm is, now the algorithm looks like very simple. Once you have the model, you have these variables, and when you have these variables, then you can calculate this. And you can is the algorithm clear? If this is clear, then there is an example. I will solve it. Just will show it. We consider the very same example that we use for the Boolean algorithm, forward algorithm, actually not for the backward one. We have two states, 1 and 2. We have two symbols, x and y. The probability that the chain starting with state 1 is 0.6 and 0.4. And we want to apply the sequence x, y, and x. We assume this one. This is the given model, or the random model, which can be converted to this one and this one. Okay. And then from this one, applying the forward algorithm, we can calculate alpha 1, alpha 2, alpha 3. We know how to do it. Following the backward algorithm, we can calculate the beta value. And summing this one will give us, after this, any question? Just I will show you one. I have one thing here. Let us consider alpha 1. Sorry, gamma 1. Gamma 1 actually is what? Alpha 1 is We need a hammered product. Point 0.04 and beta 1 is, let me write it from here, as you can see at the end, 0.2032, 0.2066, which is equal to 0.876, 0.1, something like 1. So this indicates the value of gamma 1. That means at time 1, we observe the symbol, the symbol x, y, x, and j is state 1 is 0.876, and j is state 2 is 1.124. By this way, you can calculate gamma 2, which will be alpha 2, gamma 2 like beta 2, and the gamma 3, which will be alpha 3, gamma 4 like. Once you have this one, then our next system is, and not to say this one is 5. That because the chain is starting in state 1 is 0.876, the chain is starting in state 2 is 0.124. This one is this one. Now, how will we calculate the value of 5? To calculate the value of 5, what we need to do? We need to calculate, so it's not 5. We need to calculate the value of child. 1, 1, 1. Let me calculate it. If you do it, then at the bottom we need this one. 0.069661. Actually, correct me. What is the problem? Yeah. Right? So, the answer is that. And here, if you can recall, the values were what? The first one, what we will be writing? Alpha 1 times P 1.
Did you see the
Then
final exam schedule?
5
The final exam schedule. Did you see?
Oh no.
1,
They sent it through the email.
then beta
Have the
2.
I heard I
All
was
these values will come here. This is
some message that Miras wrote
0.7,
in some group,
0.5,
maybe the WhatsApp or the Messenger group. There was a schedule. Maybe in the message.
This is beta 2.
It is the pin message. CC section, not section. It's just CC 21.
Equal to
There was a pin message about the final result schedule.
Yeah.
So by this way you can
They sent
calculate
it
this
already.
one.
I
Also
saw it
the
actually.
equation
Oh,
you
sorry.
and you can calculate
We have
chi 1,
3 courses every
then
week.
you can calculate
And that's
chi
too much,
2,
right?
1, 1.
Normally we have
Then
2.
you can calculate
Yes,
chi 2.
this time they haven't actually given much capping billion
Once you know
exams.
all the variables, then actually you need to calculate the
They
values
want,
of B11, B12, B13,
what was the reason I forgot actually?
B1.
There was a reason about not giving me
5, 1x, 5, 1y, then 5, 2x, and 5, 2. So we will have a matrix. And then we have here. Okay, any questions here?
No, sir.
So I forgot, but I will actually